Okay, to recap, the InfoCube data model, basically we are using the extended star schema to describe an InfoCube, which is a relational implementation of multidimensional data structures. That means we allow multidimensional analysis or OLAP analysis, but we are really following the traditional relational data model in that we are creating a bunch of tables that are connected through the foreign keys that I talked about earlier. Okay, so a bunch of foreign keys are used in terms of the SIDs. So the SIDs are used to connect the various tables. Example is shown in figure 5.5 in the book. An extended star schema. Basically, a star or a cube is made of two fact tables. Okay. Now in the book, I know it only shows one fact table, but in BW we can actually have two. One is compressed, the other is uncompressed. And then the fact table is connected with up to 13 user-defined dimension tables. Okay, so fact tables connected with dimension tables, and then SAP will use 3 dimension tables: time, unit, and third is data package. Okay. Let's look at the InfoCube in more detail. First, the fact tables. They are used to store key figures, as the name implies, important facts. And we can have more than one fact or one key figure. In fact, we can have up to 233 key figures. Okay, so in each queue we can keep track of a lot of important KPIs, if you will. Okay, up to 233, and we've talked about key figures in a separate chapter. You can have cumulative versus non-cumulative, for instance, and there are also 6 different types of key figures. Okay. Then for the dimension tables, as mentioned before, each dimension is made of individual characteristics, okay, group related characteristics. Each table is identified by a surrogate key. Okay, I mentioned earlier that we also, SAP BW also generates a surrogate key for dimensions. So now we have dimension ID such as DIM_MAT material, which is a primary key in the dimension table, and a foreign key in the fact table, as illustrated in figure 5.6, page 158. Okay, so if you look at the middle of the diagram, the fact table and the dimension table, the fact table and the material dimension table, okay, the two are connected by the DIM_MAT. Okay, so that's the dimension ID that connects the two tables. Okay. Whereas each characteristic is represented by its SID as well, such as SID_MAT, which is a foreign key referencing the primary key in the SID table for material. So if you look at figure 5.6, the SID table for material is at the top, which you have SID. In the SID table, it is the SID column, okay, and that corresponds to SID_material in the material dimension. So that's how you connect the SID table with the material dimension table. And again, this allows master data sharing across InfoCubes. I mentioned earlier on the on the previous slide. So now you can imagine another InfoCube that may utilize material master. Therefore, its dimension table can be connected to the SID table for material as well, to share data across different cubes. Okay. Now the exception is line item dimensions. For those line items, we have a dimension that is made of just one characteristic, right? So in such a dimension, we don't have a dimension ID. Okay. Instead, the primary key is the SID for the characteristic. So the SID is then connected to the fact table directly. Okay, so you don't have a dimension ID anymore, because in essence the dimension is the same as the characteristic. Okay, for line item dimensions. Okay, so we have explained a lot about the expanded star schema. It may seem a little confusing or overwhelming at first. All the SIDs, floating around from one place to another. Just try to understand that SAP BW uses a lot of surrogate keys to connect the individual tables. Okay, so rather than using real-world data, which takes a lot of space, they just use SIDs, which are very short, easy to process, and very quick, very efficient to connect a bunch of tables. Okay, and the real-world data, such as your material master, your customer master, and so on, can be just stored once, and then the SIDs are used to connect to the dimension tables, and then from the dimension tables are also made of a bunch of keys, basically. Okay, so they don't have actual data stored in them. They have just a bunch of SIDs plus the dimension ID. Okay, so if you look at the figure 5.6, page 158. The dimension table really just has a bunch of numbers. Okay, so they are very short and very efficient to process. So the concept may be a little bit complicated at first, but the good news is that you don't have to worry about how to build those tables on your own, as you would if you are a database developer. Okay, because the tables will be generated automatically whenever we activate an InfoCube. Okay, so you just need to know how to describe an InfoCube. Okay, in terms of the key figures, the characteristics, and the dimensions. Okay, and once you supply the definition, okay, I want 5 dimensions, and then within each dimension I have several characteristics and so on. Then you save your definition, and then you activate your cube. Then all the tables, the SID tables, the fact tables, dimension tables, and so on, will be generated by BW automatically. Okay, so we don't have to worry about the physical creation of those tables. Okay, I do want to call your attention to the naming convention for the tables in table 5.2. Let me see if I can. Yeah, page 168. For the dimension tables, remember we have, we can define how many dimensions on our own. We can define up to 13 dimensions, right? Because SAP is going to use 3 out of 16 possible. So for each dimension table, there is a naming convention that we need to be aware of. Okay, as described in the in table 5.2, each dimension begins, the technical name begins with the name of the InfoCube. Okay, so in that example, table 5.2, the InfoCube is named BWSD underscore C01. Okay, so that's the name of the cube, and therefore the first dimension gets a number 1, and the second is 2, 3, 4, 5, and so on. Okay. Now notice that at the bottom you then have, after 9, you have A, B, C, and D. Okay, and try to see if you can figure out why A, B, C, D are used there. Okay, because basically we can have up to 13 dimensions. So SAP decided that, okay, we're going to give you 4 more letters after 9 so that you can have up to 13 dimensions. Okay, but if you don't remember or don't realize that the magic number of 13, then you probably cannot understand why a dimension table can end with a letter A. Okay, because that's given by SAP. Okay, so well, at least in the past, I used to have questions like what kind of letters can we use to end a dimension table in BW? Okay, so hopefully, I mean, you can look that up from table 5.2, but more importantly, try to understand the reason that those 4 letters allow in BW because of the the up to 13 dimensions that we can create as a user. Okay. All right. To summarize, in terms of data modeling for OLAP systems versus OLTP systems. Okay. The final step is the same. Okay. Physical models. Then, in terms of OLAP systems, there are basically 2 different approaches for physical models. Okay, one is called MOLAP, actually, for multidimensional OLAP systems. So, for this type of systems, data are stored physically as in multidimensional structures. Okay, and there's no recognized standard yet, and there are some proprietary solutions out there, and actually those products are probably still evolving, and you may find new products on the market and so on. Okay, in terms of MOLAP products, multidimensional OLAP products. A second approach is what they call a ROLAP, using a relational database as the underlying structure. Okay, so relational data warehouse systems. So data is classified into fact tables as well as dimension tables, as we have explained, and they are connected by keys. In BW's example, SIDs are used to connect all the various tables. Okay, so we can perform OLAP analysis using a BW, as we have talked about before, but notice that the underlying data structure is relational tables. Okay, so the table data do not exist physically in multidimensional structures. Okay, they exist in 2-dimensional relational tables. And good example is SAP BW. Okay, so next time when people talk about MOLAP versus ROLAP, you will know that BW is one of the ROLAP solutions. All right. Finally, the book talks about some physical action when you're ready to create a standard InfoCube. actually the process is pretty straightforward. Okay, we've talked about concepts or models in a lot of detail earlier, but practically when we are ready to create an InfoCube, it's pretty straightforward. Okay, again, you just use the data warehousing workbench, and then you select to create an InfoCube. Again, remember to create an InfoCube under your own info area, and then you provide a technical name and description, and then you configure. Okay, you set up the InfoCube. The settings shows the type of InfoCube you want to create. Remember, at the beginning we talked about there are 3 types of InfoCubes. Okay, most cases we'll be dealing with a standard InfoCube, which is the default. And then you assign key figures. Okay, depending on your business requirement, you just bring in the key figures or info objects that have already been created in the system into your cube. You can use templates or direct input, just like you can with the data store object in the previous chapter. And you can then turn on navigational attributes for certain attributes, if you will. The final review question.